Hey guys, welcome back to another video lesson. We are starting a new unit today. So, new unit, new me. Our new unit is about polynomials, and we are going to start by talking about polynomials that we have already worked with this year. We have already worked with quadratic functions, right? Like x squared, something like that. A quadratic function is a function whose highest degree or power or exponent is 2. Y equals x squared is the parent function, and there are different things that you can see here. So what I want you to do right now is pause the video, take a look at these 6 examples. Okay, so you can see here in our first example, you've just got, okay, just x squared, straightforward, great. Now we've got, okay, 9x squared. All right, so it's got a coefficient and we're adding and subtracting. In the next one, we've got x squared and we've got this 2x. So whenever you're talking about the degree, right, that exponent, you look for the highest one. So even though you've got that minus 2x, the x squared is the highest degree. That's the highest exponent. In our next example, we have this guy where if you look at it, you've got y equals 5 times x minus 7. That x only has the exponent of 1, but because that 2 is there as an exponent, that's actually x squared, right? In our next example, you can see, okay, in my first factor, I've got an x. In my second factor, I've got an x. That shows me 2 x's, so that is x squared. And then in my third one, I've just got this x out front, same thing, x inside the factor. All right, there we go. So all of these have an x squared somewhere in them, or if you were to multiply them out, you would have an x squared. So those are quadratic functions with a degree of 2. The first thing that I want to talk about is end behavior of a graph. So when we talked about quadratic parent functions and that family of functions, we talked about whether it opens up or down. Recall the a value indicates to you if it's positive a, it opens up. If it's a negative a, it opens down. That is kind of indicating to you the end behavior of the graph. So as you look at the graph, if your parabola opens upward, well, on the right-hand side, it goes up, and on the left-hand side, it goes up. So when we talk about end behavior of a polynomial, or just end behavior of a function, we talk about it in terms of the left side of the graph and the right side of the graph. On the right side of the graph, your x values are approaching, like they're going higher, closer to positive infinity. And on the left side, they are going towards negative infinity. All right, so if I look at this, as the graph continues to the right, that's over here, what is happening to my y values on the actual function? Well, they are going up, they're increasing. Okay, if I look at the left side of my graph, as my x values go to the left, what's happening? Well, my y values again are going up. They're increasing and going up. Okay, for a parabola that opens downward, right? Well, in this case, on the right-hand side of the graph, right here where I'm looking, it is decreasing or going down. And then on the left side, it is also decreasing or going down. Okay, so that's end behavior. So we look at the right side of the graph, what's happening there, the left side of the graph, what's happening there. The other thing that we want to talk about are roots. We have talked about x-intercepts on quadratic functions, right? Basically, what those are values for x that make the equation equal to 0. The x-intercepts are where your graph intersects with the x-axis. So there it is. So it can go through the x-axis, or if the vertex is on the x-axis, it can actually hit it and then bounce right back off. All right, so those are 2 possible scenarios. It could also just not even intersect at all, and that we won't be focusing on that as much this year. So we're just going to focus on these 2 things, where it goes through the x-axis or where it bounces off the x-axis. So let's go through some examples here. All right, problem number 1. First thing that I want to do is take a look at my a value. I can see my a value right here. -4/5, which is a negative value. So a negative A tells you that my graph opens down. So specifically, that tells me that my right side is going down and the left side is going down. And I can see that on the graph, it's going down on the left and on the right. Then to find my roots, on the graph, I can visually see them right here. The roots are the x-intercepts. Sometimes they're called the zeros or the solutions of the graph, but I can see them where my graph goes through the x-axis. From my equation, I can also take each of these factors and set them equal to 0, because that would make the whole thing equal to 0. So x is equal to 1. Or if I took my second one and set it equal to 0, x is equal to 8. All right, let's look at another equation here. So my A value, in this case, y equals 2x times the quantity x plus 3. My A value is just the 2, which is a positive A value, which indicates to me that the right side is going to be going up. And since it's just a whole parabola opening up, the left side will also be going up. Now, for this, I do have two different roots, and I can see them on the graph where my graph goes through the x-axis. This x right here, I kind of wrote over it with my circle there, that I can still set it equal to 0. That still tells me one of the roots of my graph. X is equal to 0. Or I have another one right here, x plus 3 is equal to 0, so x is equal to -3. Those are my two roots. Or x-intercept. The x-intercept would be like -3, 0. The x-intercept would actually be the ordered pair. But the roots, the solutions, there it is. All right, next one, problem number 3. So if I look at this, I don't actually have something written out front. So if I don't have anything written out front, I can just assume I'm multiplying, it's got to be a 1. So there's an imaginary 1 written in there. And if I look at that, 1 is positive, so it's a positive A value. So I know that the right side of my graph is going up and the left side is going up. Okay, and then my roots here. Well, I can take x plus 4 and set it equal to 0. So x is equal to -4. That's one of my roots. That actually, as you see right here, that indicates that it's bouncing. Okay, that's what shows us that there is a bounce at that point. And a bounce actually indicates to us that there is a double root, right? I could take this equation and I could rewrite that. Instead of x plus 4 quantity squared, I could write x plus 4 times x plus 4, right? That's the same equation. So really, what I would do here then is I would take x plus 4, set it equal to 0. So x is equal to -4. Well, I could list it twice. Whenever this happens where the same root shows up twice, that is called a double root. All right, so I want you guys to think about everything that we just talked about. That was kind of a lot that I just went through, but it's a lot of information that we've already talked about before. And I just want you to brainstorm some observations about the end behavior of parabolas, of these quadratics, and about the roots. Okay, so take a minute right now, think in your head, write it down if you want to, and then hit play. Okay, so hopefully you've taken some time to think about some of the different things that you notice. These are the things that I noted. So for your end behavior, the left and the right end behavior will always be the same. They're either both going up or they're both going down, depending on your A value. If you have a positive A value, then they're both opening up. If you have a negative A value, they are both opening down. And both sides are going down, okay? The left and the right, both going up, both going down. Next, roots. A couple things to note about the roots. The roots are gotten by which x values make the factors equal to 0. Okay, so you take each factor, set it equal to 0. That's how you get them. Real roots, I call them real roots. We'll talk more about this later. This is what we're going to be focusing on for the first part, but Real roots are shown where the graph crosses the x-axis, which is just your x-intercepts. And if you have a factor that is squared, like x plus 4 squared, as we saw in our previous example, that gives you a double root, and the graph bounces right there, right? It's like it hits it twice. It hits it and then immediately hits it again and goes back up in the same direction it came from. That is a double root, and you get it from a factor squared. All right? So let us, actually, what I want you guys to do right now is try 4 and 5 on your own. Just identify the end behavior and the roots without actually looking at a graph. So pause and try it on your own. Okay, so you should have gotten these few answers. In number 4, A is positive, which means that the right and the left end behavior is going up. And then take each factor, set it equal to 0. Your roots are at x equals -9 and x equals -5. For number 5, you have a negative A value, which means the right side goes down and the left side goes down. Then you take your factors, set them equal to 0. You get your roots are at x equals 4 and x equals -2. This next one, let's see here. If you want a challenge, try these next two on your own. See if you can do it. So if not, you want to still go through them together, that's fine. First of all, once again, this -7 is our A value, which means that we have a negative A. So my right side is going down and then my left side is going down. Then my first factor is just this x. If I take x and set it equal to 0, that's one of my roots. And then I've got x minus 8, set that equal to 0. I get x equals a positive 8. Those are my two roots. My next one, I don't have anything in front of my quadratic, which means that it's like an imaginary 1, which would indicate that I have a positive A value, which means that my right end behavior is going up. So my left end behavior is also going up. They are the same. It's a parabola opening up. Next, I've got 2x minus 7 equals 0. Add the 7 to x equals 7, divide by 2, x equals 7 halves or 3.5. I don't care which one you use. So I have x equals 7 halves. I'm just going to leave it as that. That, because it is squared, is a double root. Okay, you will note if you have something like this on a quiz or a test, I will ask that you list it twice. So x equals 7 halves, x equals 7 halves. Those are your two roots. It's a quadratic, so it does have two roots. Okay, it just happens to be here, so it would bounce right there. All right. Next, I know you guys are super excited because we are going back to factoring, something you guys have been doing since probably before freshman year. If not, since freshman year for sure. All right. This is where you make your box and diamond, right? So different people do it different ways. I'm just going to do it like this. Draw my X, draw my dashed line. My A value would be 1. All right, so multiply these two things. All right, the first, my coefficient on x squared, and my last number, the constant. So 1 times -6 is -6. My middle term is that 5. Which two numbers multiply to give me a -6 and add to give me 5? Well, that would be, or wait, give me a positive 5, sorry. That would be a positive 6 and a -1. And then again, I just divide by my coefficient of 1. So that equals 6. That equals -1. So my two factors would be, sorry, to pause it there and double check. I thought I made a mistake. So my two roots here would be, or my two factors that I would get would be x plus 6 and x minus 1. I would set that equal to 0 to get each of my factors. So my two roots would be x equals -6 or x equals a positive 1 if I take x plus 6 and set each of these equal to 0. Right, that's how I get my roots. Okay, next, what I want you guys to do is I want you guys to try number 9 and 10 on your own. So do that right now. Pause, try. All right, so you should have gotten both of these have double roots. Number 9 has a double root at -3. Number 10 has a double root at +5. When you factor each of them, you get these same factors, right? For number 9, you would get x plus 3 times x plus 3, and you would set that equal to 0, which is the same thing as x plus 3 squared, right? All right. Great, sweet. So we've got that down. If you guys have any questions on factoring, if you want like a brief tutorial about that, you've still got some questions on this stuff, please email me as soon as possible. Next, number 11, I wanted to go over together because this one is a little bit more challenging just because we have this 3 written in. Okay, so I'm still going to start with my cross and my dashed line in the middle, but now the difference is when I multiply those two outside numbers, 3 times -2 gives me a -6. And then my middle term is 5x, so the 5 goes there. So now which two numbers multiply to a -6 and add to a 5? We already had this combination, right? So it is a +6 and a -1. All right, so that's fine. Okay, great, easy. But now here's where the difference is. Before, I was dividing by 1 because there's like this imaginary 1 right here. So that's why I'm dividing by 1 in every single one of these things. Now I have a 3 right out front. So I'm going to divide by 3. I'm going to divide by 3. And here's where the difference is. 6 divided by 3 is just equal to 2. So one of my factors here is x plus 2. The difference is here, I've got this -1/3. Well, I can't have a fraction, so this 3 I have to bring out front. So the 3 comes out front, so I've got 3x minus 1. That's my factors, okay? Set that equal to 0. Now I'm back on track. I can find my root. So x plus 2 is equal to 0. X is equal to -2, or 3x minus 1 equals 0. 3x equals 1, x equals 1/3. Those are my two roots. So I'm just going to write them down right here. X equals -2, or x equals 1/3. All right, that is all for today, folks. Have a great rest of your day, and we'll talk to you soon.